Hello everyone, hello guys. How are you? Marhay na kaadlawon sa ito. Again, welcome to this channel. Today we are to get the insulation resistance of a cable. When we say insulation, we mean the resistance of the insulator that is wrapping up your cable. In this typical figure, we specified a certain length. The current flows from this point up to the other point in one direction. That is the typical flow of current. But there is also a current that is flowing radially from the inner point of the circle of the cross-sectional area of this cable up to the outermost part. Therefore, this current is also penetrating the insulator, and we call this current as a leakage current. Therefore, it has also so-called insulation resistance, and this is what we are after to in this video. Okay, so suppose I have here a plane and I want this plane to cut through this cable, giving me the so-called cross-sectional area. So I will be having a circular figure with an inner circle and an outer circle. So you will have two radius, R1, that is the radius for the cable wire, and R2 is the radius for the insulator. And we get here a certain point in the circle, we call it as X, and another point here. Thus, getting this distance, we name this as dx, or the differential of our x. We will apply here integration this figure. Now, to get the resistance of a cable wire per se, we use normally this equation where R is equal to the resistivity times the length, specified length of the wire divided by the area. This is the cross-sectional area. We refer to the area of this cable wire. Again, the units are, we know already, for resistance is ohms, the length can be in feet, meter, and inches, and so on and so forth. The resistivity is ohm meter, ohm feet, and so on and so forth. And for the area, the square of our units. Okay, so since that we are looking for the insulation resistance, again, let us specify a length in this cable. We base our computation on this formula for the resistance of a cable wire, but instead we take it the other way around. Instead of having it looking at it in its length, we make it in the other way around, in a circular view. So the length will be from the inner point of the circle up to a certain point here in the circle, and that is x. Therefore, we rewrite the resistance formula for getting the wire resistance, which is R rho times L over A. So we place an I for the as a notation for the resistance is Ri, rho I, Li, and Ai. So R sub I is for the insulation resistance, and rho I is the resistivity as well as the length, and the radius. We know that we have here the point 1 and 2 since we are dealing with the insulator. So we have to consider the R2, the outward circle, and the inward circle. So for the length of this insulation, instead of again having it like the cable resistance length, we do it radially. So we take it from the center point of the circle up to the outermost part of the circle, since our leakage current is flowing from the inside to the outside. Okay, so we get the integration of that. We specified a certain point here and then we integrate it. The length will be the integration of our DR from R2 to R1. So that will be our X. Now for the area of the insulator, we integrate this because this is in reference to this circle, and this circle is at a certain length L, okay, to be able for us to get the L sub I. So that's why we get the DR and integrate that. So that will be the length of our insulator. Now for the area of the insulator, we get the circumference, which is 2 pi r, or x, 2 pi x, a certain point here in the figure. It will be again multiplied to L, to the length that you consider, to the length that you specified in this cable wire. So you multiply that circumference to L. Now using this formula, which is from the cable wire resistance, getting the cable wire resistance, which is rho times L over A, we have now here Ri, which is the for insulator resistance, which is equals to the rho I. Rho I is the resistivity of the insulator. This is dependent on the materials used in production. It has a resistivity, and the length is the integration of dr from R2 to R1. So you substitute it here in the numerator, and for the denominator, which is our area, that is 2 pi RL, you just copy and you substitute it here. Okay, or this will be your formula. So to get the insulator resistance, this is now your formula. So rho I divided by 2 pi L multiplied by the integration of dr over R from R sub 2 to R sub 1. Now we can further simplify this integration, this formula with integration to this formula. We apply the integration for dr over R. The integration of dr over R from R2 to R1 will give us the natural logarithm of R sub 2 over R sub 1. So you multiply this to the rho and then divide it to 2 pi L. Then the unit is ohm. So this is now the formula for us to get the value of the resistance of the insulator of a cable at a certain length. Okay, so thank you so much for watching. I hope that I have contributed to your learning desire. Thank you again.